Okay, the limitation of name node. What is the limitation of name node? Let's assume there is a big cluster where the multiple projects are running, or where the keep data is coming into the cluster, right? Let's assume that here we don't have the secondary name node. The secondary name node has been not configured here. What will happen for each transaction, or transaction in the sense keeping the data, getting the data, or storing the new data into the cluster ideally, right? When the more transactions happen, what will happen? All these transactions will be loaded into, will be written into the edit log, right? Which is the raw data, which will contain the raw information about the transaction, each transaction, right? So what will happen is after some time, the raw data, the edit log will become a huge, like it may go in GBs, right? So when it goes into the GBs, let's assume some maintenance purpose, I have restarted my cluster. When I restarted my cluster, what is the primary job of the name node to name node? It will start merging the your FS image and edit log. And what is FS image? I'll cover it. Okay. Now it will start merging your edit log and FS image. When it will merge the FS image and edit log, it will take so much of time because your edit log is huge file, and it has not been merged before. From the day one, it has been merged. Now only it has to merge all the transactions. It will end up with the huge end up with the taking too long time, right? So it will, while it is merging, our cluster will be in safe mode. While it is merging, our cluster will be in safe mode. When the cluster is in safe mode, you cannot do any transaction. Means you cannot access, or you cannot access the cluster. If you're not able to access the cluster, you cannot store the data and you cannot process the data, right? Now when the safe mode will be leave, once the merge is completed, and parallelly 80% of the nodes in the cluster, 80% of the nodes has to send the report to the name node saying that these are the data blocks are stored in my cluster. Once this 80% of the data nodes are reported to the name node, the name node will leave the safe mode and it will start functioning. It will come to live and it will start functioning. So here it's working fine, but here it is taking long time. To avoid that, to make our cluster very efficient, we will come up with a secondary name node. We, in the sense, how to come up with a secondary name node. What is the secondary name node? The secondary name node is a one machine. Then by seeing the name, you don't confuse. Like once the data node is main name node is failed, automatically will come and take over the roles and responsibilities. No, that is not the case. The secondary name node is specially dedicated to the HDFS. For what purpose? To checkpointing, I can say. What the main purpose of it? It has in a checkpoint, a specific time. It will merge the file system. Like it will take the metadata and it will start merging. It will take metadata from the name node and it will start merge the your edit log and FS image. When it will do, how frequent it will do, those things can be configured. Okay. To avoid this limitation, we will come up with a secondary name node. We, in the sense, how to come up with the secondary name node. What is the main purpose of the secondary name node? The main purpose of the secondary name node is talk to the name node namespace or file system, take the FS image and edit log and merge them periodically. Okay, that is the main purpose of secondary name node. And let's assume, take an example. We have a huge cluster. We have done a lot of transactions, and your FS image, your edit log is filed up with some data, and we have two configurations. One is the when it has to be merged and what time. Scheduling, it's like an every 1 hour or every half an hour or every 2 hours we will schedule the time, and whenever it meets the time, it will start taking the data from the name node. It's ideally file system from the name node, take the metadata from the name node, and it will start merge with your FS image. While this secondary name node merging the FS image and edit log, there may be transaction will happen with the cluster. Cluster will be still accessible. While merging, the secondary name node will take the namespaces from name node and it will be merging them. While merging these two files in secondary name node, the name node will still accessible, in the sense the cluster still accessible. You can go ahead and do some transactions. When we do transactions, where these transactions will store, the name node has a capacity where it will create two more new files, like editlog underscore new and fsimage underscore new. It will create two new files. Then what will happen? It will start keep them in, it will keep the this data into that edits that those two files. Once this secondary name node is merged this file, it will push back to the name node. And after pushing back to the name node, this with the new file, with their name node has created two new files, right? Those new files will be merged with the old files in the name node. And when the name node is restarted, it's no need to wait for a long time, no need to merge the huge number of files, I mean a huge file. It's already, once it's already merged, it can take less time to merge. And the name node will be, when it restarts, name node will be available in very less time. And that is one scenario. The other scenario, let's assume I'm doing more transaction with a cluster, and but I have configured it for 1 hour. In a 1 hour, I may do so many transactions. It means so many interactions with the cluster. But in this case, we have one more configuration called how many transactions. There is a default number is 1 million records. So you can increase it. If the transactions are reached 1 million or more than 1 million, one reaches the 1 million, the name node will start picking the file systems from the name node. Sorry, your secondary name node. Sorry, here your secondary name node will talk to the name node and take this edit logs and fs image. Again, the same job will be done in the secondary name node. Understand, right? Is this clear? Okay, please try to understand, your secondary name node is not a replacement of primary name node. Very good question. So to answer this question, let me tell you, I mean, I thought to ask this question to you guys. How many number of files we can store in Hadoop? First thing, how many number of files we can store in Hadoop? Okay, let me understand your doubt, Chandu. I have one doubt. Name node, store, meta store. Then meta store occupies how much amount of space to store each meta stores in the name node? Okay. So anyone can try to understand this answer? Anyone would like to answer this question? If anyone wants to answer, just try. Else, I can go ahead and answer this question. Okay, fine. See, the maximum number of files we can store in HDFS. How many number of files we can store in the HDFS is completely depends on your name node availability, or what are the memories available in your name node. Okay. Then here, how the memory will be calculated. For each file and each small block, or I can say each file object. Okay. See, we're keeping the files, or we're keeping the data into HDFS only, right? It be any file. It can be audio file, video file, image file, text file, XML file, CSV file, any file. For each file object and each block, it will take 150 bytes of memory. It will take for one block and one file object, it will take 150 bytes of memory. It means that if you go with 1 million files and each has only one block, it may have multiple blocks, right? If each has only one block, then your memory will be close to 3 GB. In the name node, it will occupy close to 3 GB. Okay, that is the reason our name node should be high-end machine like 128 GB RAM or 512 GB RAM or 258 GB RAM. More, the RAM should be more in the name node, not in the data node. Data nodes can be in commodity hardware, but name node cannot be in a commodity hardware. If you want high performance and if you want the, because name node is a single point of failure, it should not frequently fail. If it's fail, we lose everything. We cannot talk to the cluster. Okay, it will take 150 bytes of memory. It will take 150 bytes of memory for each file object and block object. See, each block objects only, right? Ideally it is storing in objects form only, right? Okay, for each file and each block object it will take 150 bytes of memory. Okay, so here Raghu, I'm not sharing my screen. Okay, not yet shared. I'll share the screen. And how much data or how much space it will take completely depends on your name node space availability, and how much memory should be there in memory there should be there in the name node. It can be it's if you are going to use a huge cluster, or if you are going to store minimum to minimum, as I know, minimum to minimum it should be 128 GB RAM in the name node, or 64 GB of RAM. Name node should be there. Okay, I think I have cleared your doubt, Chandu. If you have still doubt, please go ahead and ask. I can try to answer. See, whatever we store in our data nodes, whatever we store in the cluster in the form of files or blocks, okay, everything will treat it as an object. Everything will represent an object. So it will be treated object in the name node memory. So that object will occupy 150 bytes of memory. Okay, I think I have answered that question. Now let's go back to our secondary name node. Understand about the secondary name node roles? Any doubts in the secondary name node? Bharat, Raghu, Vamsi, any doubts? Okay, okay. Now, what is edit log and what is FS image? Okay, edit log is a file. So I can say it's a log file where it will store all the transactions. Whatever the transactions you do with a cluster, all the transaction will make an entry into a edit log file. It will make an entry into where it will make an entry in a edit log file. Okay, then each entry will go in what form? Each entry will contain the transaction ID, cluster ID, file. I mean, what is the operation they have done? All the details will go into your edit log. Next, and what is the FS image? FS image is a copy of edit logs, but in the form of it will be your FS image will contain information like permissions and what is the file and the files, how many blocks and what is the block and where it stores. All the information will be there in the FS image. This FS image will be loaded into the memory, name node's memory. This FS image and edit logs will persist in local file system in HDFS. Sorry, name node. These your FS image and edit logs will store in name node's local memory. But when it comes the RAM, in the RAM, it will be having the FS image. Okay, how frequent it will be merged? It depends on the configuration. what are the configuration we have made, either 1 hour or 1 million records, 1 million transactions I can say. So it will start merging them. Okay. And if anyone wants the those configurations, I didn't remember exactly. It is like checkpoint. I think DFS dot name node dot checkpoint. I think let me checkpoint dot transactions period. Okay, here we will be. Okay, let me put the complete DFS dot name node dot period. This is the what is the period, and other one is DFS dot name node, because we're talking about we're handling with the name node dot maximum number of transactions, checkpoint transactions. I hope, yeah, checkpoint transactions. I think TRNX or TXNS. I think transactions. Okay, transactions. You guys can check it. The file. So here we'll get these are the two main configurations where you will configure how frequently your secondary name node has to interact with the name node. Okay, fine. Where FS image and editlogs makes checkpoints. Uh, no, can you reframe your question, Chandu? No, could you please reframe your question? I didn't understand. FS image and edit. No, FS image and edit logs make checkpointing to create a new FS image. No, FS image and edit logs will not make, right? We have given the configurations. Those configurations are to name node. If your name node reaches these many transactions, transactions. See, if you want to talk to the cluster, to whom we will talk? We'll talk to the name node only. If your name node get these many interactions, 1 million transactions, 1 million files has been written, 1 million times it has been talked to the name node. So then it will call your secondary name node to merge the edit logs. Edit log is an FS image are just like in files where the data will be stored. This never makes the checkpointing. These guys don't know anything about it. Those two configurations, hourly basis or transaction basis, those two configurations will configure. One is for hourly basis. Another transaction you can make 1 million or 1 million, 10 millions. How many transactions you would like? Okay. Once it reaches those threshold, it will talk to the name node and will start merge them. FS image and edit logs will get merged. Checkpointing will happen because of those two configurations. There is no relation with the checkpointing and FS image. FS image are just like a files. Okay, these will store the data in the sense information about the data. I can say transactions. These guys will just store the data. FS image is the copy of edit logs in the proper format. FS image will contain what is the owner, what is the permission, what are the permissions are there, what is the file, what is the block, okay, where it is stored. That information will be there in FS image. And when it comes to edit log, the raw transaction in the sense Hadoop put command or Hadoop no, you have checked some commands. Those things will be there in your edit logs. We will see them. We will see detailedly. We'll try to look at the edit logs also. But I think in Hadoop 1 it is not possible. We don't have any tools. And when it comes to Hadoop 2, we have two different tools where you can read. FS image and edit logs are byte format. Those are not human readable. So if you want to read edit log and FS image in Hadoop 2, it is possible. Hadoop 2 come up with the two different tools where you can view FS image and edit log files as well. I'll give that command also. It's a very simple tool. It is a command line tool. It's a built-in tool in Hadoop 2. Okay, is it clear your doubt? Chandu, is it clear your doubt? Is that only your question or something else? Okay. Okay. Where? Yeah. Now my question is that you guys try to answer where this FS image and edit log files will be persist in the cluster. Where these two files will be there. I know it will be there in the name node. Where in the setup? Okay. Let's assume in our pseudo distribution mode where this will be stored. We are doing the pseudo distribution mode, right? Where this FS image and edit log files will be there in our local your in setup, at least in our setup, where we can see them. RAM. Any other guess? Umsi, Bharat, Raghu, Swapna, anyone can answer. No idea. Okay. No, it will be RAM, but I'm asking about even a local machine where it will not be in a RAM, it will be there in local file system as well. In the local file system, where it will be there? Which is the location? Have you any time try to see, look at? Okay. In your Hadoop installations, we will give the name node data, right? We'll give one folder. We'll give one folder where the name node, where the data will go, and name node folder and data node. Yes, dfs.name or dot date. No, not in C drive. Ideally, it's not in C drive. Okay. So in the setup, right, we will give the configuration HDFS site.xml. We'll give the configuration.dfs.name.dir. There we will be having we'll give the some path like user local Hadoop data DFS name. Inside the name, you go and see, you'll find the name current. There will be one folder called current. In that folder, you will find this. Okay, let me show in my screen. I'm sharing my screen, guys. Are you guys able to see my screen? Please, anyone can answer. Are you guys able to see my screen? Okay, it seems you guys are able to see. Okay, fine, good. Let me go to the my setup. I'm going to my setup. I think this is the place where we'll keep our this is the our Hadoop folder, right? If you see, this is our Hadoop. Inside the Hadoop bin and all are there, right? And where we have given data. Okay, before that, let me show configuration file. Go to configure and you see your HDFS. Okay, where is the DFS name.dir? Where is the location? It is a user local. It is my setup. In your machine it may be different. Hadoop DFS and name, right? This is the location, right? This is the location. Where is the location? Hadoop DFS name. We'll go and see that. Where it is? Hadoop. Where it is? Hadoop. Okay. 1 second. here. This is MacBook, right? I have some problems with it. Okay, so let's assume this is my user slash local and backup Mac, backup for Mac. Go to my Hadoop. Okay, in the Hadoop I have a DFS. In the DFS I have a name. In the name I have a current. See here FS image and your edit. Okay, so I think these are not human readable. So you cannot read anything here. Okay, and sorry, where is that? On your FS image as well. The same way your FS image as well. Yeah, it is something. It is not proper. No proper format, right? It has some information here. Supergroup and permissions and what are the data. ETL one. It is my real time data. I'll be keeping here, right? The dates and what are the permissions. This some details are there in FS image. Clear, guys? I mean, there are some other folder structures like my Bluetooth disconnection, my phone batteries, and phone network. I have some because it's my setup, so it is showing something. You know, setup it may show different. Clear? And what is a version file here? What is a version file here? Okay, see here, your namespace ID is this, and your layout version is this. Sometimes your version is corrupted. Sometimes your name node will complain that version is not matching. Because of that, the cluster is not come up. That time you can just come here, delete this file. Just come here, delete that file, and you can your cluster will start running. Clear, guys? And your previous checkpoint. When in the previous checkpoint, it will be merged the files, right? Here and data is for the data node configuration. If you go and see, what is your data node configuration, dfs.data dir, this is the name. Inside the name only I have taken data. You can take outside also. It is up to you. It's totally up to you. Okay, in the data again I have a current. See here in the current I have block information. Okay, blocks and subdirectory information. These are the blocks, right? Blocks.metadata. This is in data node. This is in data node, not in the name node. We are looking in the data node. We are looking in the data node where the block is there. This is some address, some metadata about this. Why? One block and its metadata. One block and its metadata. Right? And fine. And also one more thing here. And blocks being written. Nothing is there here. And if you try to see at your setup also, all this should be there. Okay, what is this temporary folder? This temporary folder will give a temporary folder for your name node, I mean your data node what's processing. The intermediate data will store temporarily in this temporary location. For the temporary location we should have a different temporary location than your Linux temporary location. See, you can create one temp folder anywhere. If you give same temporary location like your Unix temporary location, okay, let me show that configuration file, then you can easily understand. While you are configuring with temp location, it will come in. Where is my configuration files? Okay, this is compression wala. I think that is in coset.xml. Yeah, this Hadoop temp location, temp directory. Okay, this temp directory, suggest you to give different locations than default location. The default location will take your temp folder, your Linux system temp folder, like this one. This is your unique location temp folder, right? Why I'm telling that don't give this temp location, because the default will go here. Fine, sometime for temporary data it's fine, but we should not give our data. See, if we go and see here, okay, let me close this, and let me also close this. In HDFS, this location, why we are giving separate location here, we are giving separate location here. Here it is not preferred to give your temporary location, because the temporary location in the temporary folder in Linux machines will be deleted automatically every 10 days, or some threshold will be there for that. It will be cleaned up. It will be cleaned up by default by your Linux operating system. That is the reason your data name node and sometimes the temporary location also will not refer the Linux machine temporary location. We always prefer to give some other location than the temporary location. Okay, now I would like to show you whatever the data you store in HDFS, that data will have a sum checksum. For each block, it will store the checksum. What is the checksum? Checksum is a what kind of string, or I can say one identification number, one some metadata information about the block or whatever the data or file, that will make sure that that block is unique. That will make sure that the block is unique and it's not corrupted. And what does it rule follow? It will follow CRC32 rule. I think there is some organization, there is some rule for it. It will follow the CRC rule. What is the CRC? Cyclic redundancy check. If you see in our Hadoop cluster, if you're able to see, it will create for each file. It will create one CRC file. Let me show you that. Time slash ETL on output. Okay, I'll select one date ls. It has these many folders. Let me take Bluetooth connect or BT call, whatever it is. BT call state. When I do ls, I have okay ls hyphen. If you see here, crc file dot crc file. Why it is dot crc file? It's kind of checksum. Okay, this is actual map output. This is my map output, which is there in compressed format, gz for compressed format, and this is the crc file. This is a kind of checksum file. Whether this file is corrupted or not, it will be confirmed by this file. Cyclic redundancy check. Okay, fine, clear, right? Clear, guys? Any doubts? Let me. Oh, some guys are pinged here. I don't know. I didn't see clear. Okay, it's clear. Okay, fine. Okay. I hope you guys are clear about the secondary name node, and you guys are clear about the FS image and edit log. How can we know that file corrupted or not? We will not come to know whether the file is corrupted or not. Your cluster or your client will come to know whether the file is corrupted or not. When you're trying to access, when you're trying to read the data, it will say that whether it is corrupted or not. Okay. Any other doubts, guys? If you guys don't have any doubt, I will just now continue with one or two examples. When corrupted data will come in, when corrupted data will come, it will take. No, it's not like that. When the data is corrupted, somehow some let's assume there is some situation, there is other person also trying to access your data, and he something he added, he changed the name, or he he changed the block name, or he changed the file name, or he added some content to that file, that time the checksum will be checksum will not change, but checksum will be the unique for the old data. And whatever whenever you modify that block, it will say that the block is corrupted. You have changed some data, it has been accessed by some other person, so some other third party server or something accessed, and they have done some modifications. That time your checksum, your crc file will crc file will not modify, because the crc file will be created for the old data, and someone has modified that block, and they have added the data, or they have changed the name of that file. So something happened to that block, then the crc file will be same. So when you try to receive the data, it will check the crc file, it will check the checksum file, and if the checksum file is not same, it will say the data is corrupted. Okay, any other doubts, guys? I hope it's clear. I think about secondary name node, about edit logs, and about fs image. Okay, now the secondary name node, Ravi, you're telling that it'll do now secondary name node will start merging, right? How will I get the size of it? How will I get the edit size? Or if I say in the name node only, how will I get the size of edits? How will I get the size of edits in a name node? Forget about the secondary name node, we'll talk about that. In the name node only, I want to see what is the size of my edits. How will I see size of my edits in name node? Guys, these are the real-time scenarios. Okay, you will check these things ideally. The not even the sense, not the developer, at least administrator will try to look at them. Okay, there is a command called Hadoop. You can say what is the command? I think I remember hyphen get edit size, get edit edits size, edit size, get edit size. I think it is think here secondary name node. Secondary name node. I think this is the command. It will give the size of edits. Okay. 1 second, sec, guys. Let me take some water. Okay. Now I have one question to you guys. My name node is completely dead. Completely dead. Okay. Is there any data loss? My name node is completely dead. Is there any data loss? Please, guys, try to. You logically think. Don't think. That's what I'm trying to say. In interview, when you go for interview, don't try to think whether you have read it or not, whether you know it or not. You try to think in logical way. Say I'm talking about the data node is completely failed, so what will be the situation? Now we know the complete architecture, right? So what will be the situation if completely data node is dead? Is there any way to get the data? You try to think it logically, then you will answer the question. At least you will reach some point, the interview viewer will be impressed with your logical thinking. Okay, please, guys, what I'm trying to ask here, If name node fails completely, so is there any data loss? No data loss, metastore will be available. Namespace. In namespace, okay. Okay, I'll clarify your doubt. I mean, this is partially correct. No, it's not partially correct. I think say in Hadoop 1, by using secondary name node, it is data loss will be there. Little amount of data loss will be there. Okay. And any other guesses? I'll explain you Prabodh. I'll explain you Chandu. Any guesses from Bharat, Raghu, Vamsi, Swapna, anyone? This will be question from your interview. Sure, at least if you want to understand your architecture level knowledge, he will ask this question. If my name node is completely dead, so will be there any data loss? Okay, fine. Let me answer myself. Yes, there will be little data loss. Why? Let's assume I have configured the secondary name node. Okay, I have configured the secondary name node and I have configured the configurations like every 1 hour. I have to take the namespace from the name node. I mean, file. Take the name. Contact the file system in the name node. Take the data and merge it. And there is one more configuration. 1 million records. Right. When it reaches 1 hour or when it reaches the 1 million records, it will start merging. Let's assume that it is start merging. Okay, it start merging. Then that there are some transactions that happen from 9 o'clock the transactions happen and there will be next transaction in 10 o'clock only, right? In between 9 to 10, in between there are some transactions are happen. In between there are some transactions are happen. So those transactions will be saved where? Those transactions will be saved in, try to answer guys. Those transactions will be saved in, no, why secondary name node? The secondary name node will come into after 10 o'clock only, right? 9 o'clock is a one, yeah, correct. It will be there in name node, right? It will be there in name node. Now name node is completely, yeah, in edit logs only, but it will be there in name node. Now the name node is completely failed, so we'll be losing the data for last transactions. See, 9 o'clock my merges happen, fine, well and good. Next merge will be 10 o'clock. Yes, exactly. So now the latest and recent data, what are the transactions that happen, those will be lost because the last merges happen at 9 o'clock. The next merge will be 10 o'clock, or if the records reaches to 1 million, right? In between, let's assume that I didn't reach 1 million records. Let's assume that after half an hour, 9:30 or 9:45, my mission is failed. So the recent and the latest the transactions that will be lost. Then when you recover the machine by taking the secondary name taking the secondary name node and you merge them and you make up that, but you will be losing the last 1 hour or last transaction, recent data will be lost. Guys, to avoid this problem, Hadoop to come up with another two more beautiful features called checkpoint node and backup node. Okay, we will see what is backup node and what is the checkpoint node in detail later session. Is it clear, guys? Is this clear? Is it available from which version? Hadoop 2 onwards. Hadoop 2. Hello. Yeah. Someone wants to talk. I think someone is enabled. Hello. Sorry, guys. I'm getting some disturbance. Bharat, I think he wants to talk, right?
Hello.
Okay. Okay. Fine. No, I'm getting some disturbance from your end, so that is the reason. Okay, so shall we? Everyone setup is ready. If everyone's setup is ready, then we'll see one or two commands how to put the data. I mean, we'll see some of the simple commands. Okay, fine. I think I would like to see Vamsi's setup. So if anyone wants to stay back, you guys can stay back, or if anyone wants to leave, you can leave. So I'll be covering tomorrow backup node, checkpoint node, and we will see what we are trying to understand here. We are trying to understand complete architecture. Complete architecture, like what are the nodes available? What are the terminologies I can say? Checkpoint node, backup node, and so high availability. We're trying to understand these things. Once we are very strong in these areas like architecture level, then we can go with the programming side. If until unless we are strong in this area, I would not recommend to go programming and simply do the program and complete the course. Okay, I want you to be good into these areas, like what is backup node, what is secondary name node, what is primary name node, and what is the data node, how it will work, how internally these things are managing. I want to make sure that you guys know these things. No, fine, we will just see the setup. Once the setup is ready, then only we can continue with other things. Okay, I'm just stopping the recording, and I'm just stopping the screen sharing as well. I want Umsi to share the screen, so I'll be stopping the recording.